Dangal greetings everyone and Dangal greetings Sir Janus. We are the Group 4 and today we are proud to present our learning management platform system that is designed to systematically manage teaching assignments, student enrollments, and automated fee calculations. Our team built this system strictly adhering the object-oriented programming principles, specifically the encapsulations, associations, aggregations, and inheritance. So let's welcome Cassandra and Nicole Sante to explain you more about the UML class diagram.
Dungal greetings, I'm Cassandra Nicole Santa and I'll be discussing about our class diagram which represents the structural architecture of our learning management platform, which we designed in Java to automate the tracking of instructors, courses, and student enrollments. Starting at the top left, the instructor class acts as a manager in our system. It uses a static ID counter to ensure every instructor gets a unique identifier automatically. You'll notice the minus symbol next to the attribute like ID and name, which represents private visibility, meaning this data is encapsulated and protected from outside interference. This class is connected to the course class through an aggregation relationship shown by the hollow diamond. In our code, this means an instructor holds a list of courses, but since its aggregation, those courses can still exist independently if an instructor is reassigned. The course class is the functional hub of the system, storing the specific number of lessons, which is the base variable for our fee calculations. The multiplicity here shows that while every course must have one assigned instructor, an instructor can handle one or more courses. The course class also aggregates students, allowing administrators to enroll or drop students dynamically. In the center, we have the student class, which is our parent superclass. We use symbols for attributes like ID and name to indicate protected visibility, which allows our child classes to access this data directly. You'll see a dash association line pointing from the student back to the course. This reference is vital because it allows the student to see how many lessons are in their course to compute their payment. At the bottom are our specialized subclasses connected to the parent by inheritance, shown by the open triangle arrows. Both regular student and scholar student inherit all the properties of the parent but use method overriding to handle different financial rules. While a regular student pays for the full rate of 120 pesos per lesson, the scholar student applies a 30% discount automatically. By using this polymorphic design, our platform can process any list of students and automatically apply the correct billing logic based on the specific type, creating a system that is both secure and highly efficient. Thank you for your time.
Greetings everyone, I'm Franco and I'm part of the group 4 in 2CSA. So I will be discussing the class relationship and multiplicity of our system. So our system has 5 classes, contains a instructor, course student, regular student, and scholar student. So the first relationship is between instructor and course. This is an aggregation relationship with a multiplicity of 1 to 1 or more. One instructor can handle one or more courses. Courses can still exist independently from the instructor. In test case 5, we can see this when web development is removed from Prof. Santos. The second relationship is between course and instructor. This is an association relationship with a multiplicity of many to one. Each course is assigned to only one instructor, but one instructor can handle many courses. This is shown where Java programming and the web development is assigned to Prof. Santos and data analytics to Prof. Reyes. So the third is course and student relationship. This is an association relationship with a multiplicity of 1 to 0 or many. One course can have 0 or more students enrolled. In test case 2, Juan and Maria are enrolled in Java programming, while Anna is in data analytics. The fourth relationship is between student and the course. This is also an association relationship with a multiplicity of many to one. Each student can only be enrolled in one course at the same time. In case test case 4, Maria Lim is removed from Java programming and her enrollment become empty. So the fifth relationship is between student and regular student. This is an inheritance rate. So the fifth relationship is between student and regular student. This is an inheritance relationship because regular student extends students and inherits its attributes. A regular student pays full fee of 120 pesos per lesson with no discount. For example, Juan de la Cruz with 10 lessons pays full 1,200 pesos. So the sixth and final relationship is between student and scholar student. So this is also an inheritance relationship. Scholar student is also extends students but overrides the fee computation to apply a 30% discount. The rate becomes 84 pesos per lesson. For example, Maria Lim with 10 lessons pays only 80 840 pesos. So that includes the class relationship multiply. So for the summary of all of this, our system uses aggregation between instructor and course, association between course and student in both directions, and inheritance between students in its two subclasses, regular student and scholar student. This relationship works together to properly track instructors, courses, students, and automatically compute fees based on student type. So on to the next reporter. Thank you.
Okay, here I am again. I am Radyn Maloles. Now I will be walking you through the foundational architecture of our system. First is the data protection and automated IDs. Across all the three of these core classes, you will notice two major things. First, we use encapsulations. So all the attributes like names, course titles, and the lesson counts are strictly private and can only be accessed through specific getter and setter method. Second, we implemented a automated ID system using a static counter. So every time the new instructor course or the student is created in the system, they are automatically assigned a unique ID starting from 1. Now let's proceed to the instructor class. Aside from the basic details, so an instructor needs to know what they are teaching. So to solve this, we use an aggregation so that the instructor class hold a private list called handled courses. So we use assign a course to an instructor so it gets added to the list securely. Next is the course class, which acts as the bridge of our system. It demonstrates both associations and aggregation. It has an instructor field to associate with who is teaching it and the list called enrolled students to track who is taking it. The smartest part of our course class is how it handles updates. For example, our drop student method, when a student drops a course, the system doesn't just remove them from the course roster. It simultaneously clears the students or a personal enrollment record. So this two-way synchronization ensures that our database is never mismatched. Finally, we have the base student class. It tracks the student personal details and includes an enrolled course associations. Importantly, this base class contains our default calculate fee methods, which simply implies the course total lessons by our fixed rate of 120 pesos.
Greetings everyone, I'm Chris and Karsten, and I'm going to explain the main diagram. So first we have a line of code that serves as welcome header. So next is the instruction, which is the line of code that initiate two object of the class instructor class, specifically creating the prop Santos and prop Reyes entities with their own unique IDs, empty list of handle course. So next line of code is the course. So this line of code initiate three unique course objects. So assigning each specific title and set number lesson to be used for fee calculation and instructor assignment. So next is the student code. So this line of code demonstrates the polymorphism by initiating a specific regular student and scholar student object while storing the storing them in student reference, so allowing them the system to handle different student by types through single common interface. So next line of code is the collection. So this line of code organizes individual object into list collection, so making it easier to manage and iterate through all and instructor courses and the student. So next line of code is or block of code is the demonstrate object association, nested iteration by linking specific instructors to their perspective courses, and then traversing the aligned structure, please display each professor the full teaching load. So next line of code is demonstrate the object interaction and the state management by enrolling specific student course and iterating through the course list to display the enrollment status of each course, uh, including a conditional check for empty classes. So next is this is the next block of code. So demonstrating dynamic binding, iterating through the student list and automatically calling for a calculate fee. So remove student. So this block of code demonstrates state synchronization and object decoupling by invoke the drop student method to remove student from a course list and stimulately updating the student enrollment and update the status to not enrolled. So next block of code is or the last block of code is demonstrate bidirectional relationship. So management by invoking the remove course method to decouple the instructor from a specific course. So updating both the instructor list and course reference before displaying the remaining teaching load. So that's for our main.java program.
Donald greeting. So for continuation, I will explaining the scholar student Java. So first line of code is the Java override. This block of code demonstrate the method of overriding by invoking the parent class calculate fee method user using the super keyword and applying 30% discount. So scholarship discount to resulting the value. So next is we have also override. So this block of code demonstrate the method of overriding by providing a specific implementation of the get student ID or get the student type. So this method that returns a unique string identifier for the student subclass or scholar student subclass. So next is for continuation also, uh, I will explaining this small line of code for the regular student. So this block of code demonstrate method like same as the scholar student. This method overriding providing a specific string, so identifier that allows the system to distinguish a regular student from the other student types during the runtime. So that's all for my part, the main Java, scholar student, and the regular student. So thank you.
So to wrap it up, building this learning management platform taught our team how to handle real-world scenarios into scalable and maintainable software through strict object-oriented programming. So one of the biggest challenges was handling dynamic phase calculation, which pushed us creatively leverage standard inheritance and achieve clean and efficient logic. So developing complex associations like ensuring that the dropping a student simultaneously updates both the course roster and student personal record highlight the importance of bidirectional updates in maintaining absolute data integrity. So we are incredibly proud of the robust architecture we built into the lab exam today. Thank you.